Hello, welcome to Lab 1, Charge Tapes. So some introduction. The purpose of this lab was to prepare two pieces of tape and observe their interactions due to the electrical charges between the two. Then we were to create a computational model to represent the relationship, compare the two, and answer some last questions. Some fundamental and key concepts we need to know before going in are Coulomb's law, which is the electric force, gravitational force, and Newton's second law, which is F net equals 0 according to inertia, or the momentum principle. Some assumptions we made before going in were that there was no air resistance acting on the tape. The long tape is a point charge with the charge concentrated at the center, and the U tape has an evenly distributed charge. The main results of this lab are that the magnitude of charge on both tapes were 1.4 to the 10 times 10 to the 8th power negative 8 coulombs. This is a positive number, which means both tapes were positive and repelled each other. And they were deficient of 8.75 times 10 to the 10th power of electrons. That's why they were positive. So for the experiment, we had our system, which was tape A and tape B. Then we had our surroundings, which was everything else. And initial conditions are that everything is neutral. Nothing has a charge yet. So the process to create this charge is to take a U-tape or create a U-tape. So this is our tape B. We put it on top of a base tape and ripped it off really fast. And this created a loss of electrons and created positive charge. But we didn't know that when we did it, so that's why we had to do step 2, which is when you take your hand and it's attracted to it. Your hand is not negative charge, and so when the tape is attracted to it, we know that it must be an opposite charge, meaning it's positive. Additionally, when we took another piece of tape, A, and put it down here next to B, B was repelled, meaning both A and B are positive because there was repulsion. With that, we created a computational model with some known values. We have all the fundamental equations right here that we talked about in the first slide and some variables. And then over here we have the tape's mass, the tape's length, the tape's width that are all estimated, and the distance between tape A and tape B when they were repelled right there. So we measured those and inputted that there. Then we got this computational model, and this is where we got those numbers from the beginning. It created it for us. It has the electric force going upwards and the gravitational force going downwards. This is tape B and this is tape A. So some comparisons between the two. Obviously, the true experiment didn't involve point charges, whereas the computational model did for simplification, but that's what it's for. It's a simplified and simulated model in a perfect world, so the experimental model may be a little different. But however, in the end, the point of the model is that the electric force points upwards and the gravitational force points downwards, and both charges are like, so it is repelled. That's why the electrical force is pointing upwards. Some questions that may arise from this lab are, what if electrons have positive charge and protons had negative? So we switch them. So basically that just means the electric fields would swap between the two. But visually nothing would change since like charges still repel and opposite charges still attract. And then why is it important to handle these charged tapes as little as possible? And this is because if you tamper with the tape, your hands can transfer electrons, and that can mess up the charge if we want it to be negative, positive, or neutral. So in conclusion, some possible sources of error are that, just like I said, that mishandling of tape. I may have touched it a little too many times. The pieces of tape may have had differing charges. They may have been different lengths, different widths, and also we assumed air resistance was negligible, which may have had a slight part in the lab. But in the end, the results are indisputable. Like charges repel each other, electrons can be lost and create net positive objects, and electric charge is everywhere and plays an important role in our physical world. Thanks for watching.